This is Objective 1.9, compare and contrast IPv4 address types, and they're going to be unicast, broadcast, and multicast. Those are what we have. Unicast, one-to-one, broadcast, one to everybody we saw in the demo in the last segment, and then multicast, which is a group of machines. You might subscribe to a service, for instance, in order to do that. So, unicast, single destination address, ignores transmission up here. So a unicast here is we're going from this one, maybe the .1 address to the .2, .1 to the .2 address. And remember, we're actually going to be eventually getting to the MAC address. We're going to use the ARP protocol to translate the IP to MAC, to the 48-bit MAC address. An address type that is used to communicate information from one node in a network to another node. Packets of data are sent from a source address to a particular destination address in the network. The other nodes in the network are not identified in the unicast address. Ignore the data transmission. Unicast is predominantly used in LANs and the internet to get to a particular thing. If we want to go to www.google.com, that's where we want to go, not to a whole bunch of other places. So unicast goes to a specific address. If we want to go to the server where our home directory is, then that's the IP address that we want to go to. Popular applications: HTTP, SMTP, Simple Mail Transfer Protocol, and FTP are used with unicast addresses. So again, unicast goes to an individual device. Broadcast, kind of saw an example of that earlier. Broadcast in this sends a transmission. If we send a transmission to the 255 address, the broadcast address, we'll say 255 for a class full network, all ones in the host, the broadcast, then it's going to go to all of the stations that are in that network, in that broadcast domain, in that IP network. Used to communicate information from one node to all other nodes in a network. Packets of data are sent from the source to all the other nodes. Broadcast address identifies all the nodes connected to the network. And when we do this, the 255 is going to, in the switch, is going to create an FF. 1, 2, 3, 4, FF. And all Fs, and that is a MAC broadcast address is all Fs. Typically used by a network node to check for the availability of a particular service on a network. If we do like an ARP, tell me who has this address, we're going to ARP to the broadcast. Because we don't know who has that MAC address, we want to know who has that MAC address, so we send it to all of the stations on the network, and one of them will then reply with a MAC address associated with an IP address. Also used by servers to advertise their presence to network nodes. If we're having a service and if you want to advertise to everybody, obviously you're going to send it to a broadcast address. Huge amount of traffic, and that's why we want to subnet, so that we don't have the traffic going to everybody, only to those stations that actually need it. Isolation will reduce the amount of broadcast traffic that we have on our network. A multicast is kind of a different animal. A multicast, and this we're going to find is used a lot in routers, we'll say routers, in dynamic routing protocols. I know we haven't talked about them yet. Dynamic routing protocols. What those are, PROTOCOLS, are protocols that routers use to talk to each other to share information. So if we're running, and this is another one, EIGRP, which is one of those protocols, then all of the routers that are running EIGRP are in the EIGRP multicast. So any EIGRP traffic that goes on the network will go just to those routers, and the multicast distinguished by 224.something.something.something when we do those things. So in this, if we send traffic to the multicast group, it only goes to, here we're sending it this way, it only goes to those hosts that are actually part of that. It's used to communicate information from a source to a set of nodes in a network. A set of receivers predefined as a multicast group. Other nodes which are not part of the multicast group ignore the transmission. Unicast broadcast is used to communicate with other nodes on the network. A video server to transmitting TV signals may be an example of something like this. Bandwidth conservation due to reduced traffic loads. And as I recall, starting in maybe it was Windows Server 2008, there was a broadcast group that was used to install a multicast group that could be used to install Windows, so that it would start the multicast, the machines would be subscribed to it, and it would then send that information only to those machines. Meant that each of them didn't have to have an individual connection in order to get the software install files. So summary, quick and dirty on this one. Types of addresses: unicast are one-to-one, kind of defined in the name uni. Broadcast, just like in a broadcast radio or a broadcast television station, goes to everybody. And then multicast goes to those hosts that are subscribed to that particular multicast. The next topic, we're going to talk about IPv6, and we're going to roll up all of the IPv6 objectives into one, and we may have to wind up splitting it, but we've got one presentation. See you there.